All right. When you look at a solubility table, show all these letters, and let's look at strontium phosphate. It's got that A right there. Strontium phosphate, it's A. A means insoluble in water. Anyone that says insoluble or A insoluble in water, like it's like P, partially soluble or slightly soluble, we're going to explain what that means. Even though it says it's insoluble, it's a bit of a misrepresentation of the truth. We're going to use a PhET simulator, all right, to help us figure this out. I have that same thing. See, I've got strontium phosphate up here, all right? Now I'm going to add some, oops. I'm adding some strontium phosphate to this thing. And you'll notice that some of it is actually dissolving. If you look up here, some of it is actually dissolving. All right? If I add a little more water, those numbers are going to go up. Okay? Now, all right, so even though on the sheet it said it's insoluble, this compound, strontium sulfate, is soluble to a degree. All right? Now, I'm going to pause the video and let some. So I let a little water out. Some of the ions go out the little tube. I'm going to let more out. So I've got this amount of volume. If I were to let the water out, less will dissolve. These numbers are going to go down. Okay, now it was at like 68, now it's around like 50. All right? Insoluble salts are soluble. All right? All right? A small amount will dissolve. All right? So if I've got a beaker of water and I've got an insoluble salt in here, and I spelled insoluble wrong, there's actually going to be a little bit of it in the water. All right? All right? Let's say this one example of this is silver chloride. Silver chloride is insoluble, but if you put, there'll be a little bit of silver and chloride ions in there. All right. The KSP, which is the solubility product constant, tells you how soluble. As it gets bigger, solubility increases. All right? Here is silver chloride's KSP product. It's 1.77 times 10 to the 10th. All right? That means it's still very little in there, but that's what this number tells you. These are the solubility product constant, and that value tells you how soluble. Now, if you look over here, lead phosphate is 1 times 10 to the 54th. That's like really, really insoluble. However, some would still be able to get dissolved, all right? This value was 1.1 times 10 to the 10th. I think that's what it was. I'm going to look. 1.77 times 10 to the negative 10th. All right. So even though something is insoluble, it doesn't mean it's actually, none of it's going to dissolve. Small amounts will. All right. Example is silver chloride, calcium carbonate is another one. All right. And what tells you how soluble it is its KSP value, its solubility product constant. As that goes up, solubility goes up. All right. And they're typically only going to be a negative exponent, like a very small decimal. Okay.